Hi viewers, this is a short video on Introduction to Digital Signal Processing and its significance. Let me elaborate what we'll be covering here. We'll be covering what is a signal, what is signal processing, applications of signal processing, and the prospects of signal processing. So what is a signal? We live in a sea of signals, and signals could be either natural or man-made. Electrical signals are everywhere in communication, in entertainment devices, in measuring instruments, in imaging devices, in computers. So a signal is a physical quantity that varies with time. We have audio signal, we have video signal, we have an image, okay, we have any quantity that is measured over time. For example, a temperature, when it is measured over time, you can see the varying nature of temperature with time. That is a signal. ECG, which is also varying with time, which gives the signal about heart. Audio, speech, all these are examples of signals. The electromagnetic radiations that we get from the towers, that is also a signal. So what is signal processing? Manipulating a signal to change its characteristic or extract information is called signal processing. And to perform signal processing, we use devices like computer, analog electrical circuits, special purpose integrated circuits, etc. Now, DTSP is discrete time signal processing, which could also be referred to as digital signal processing. Signals in nature are analog. Analog circuits uses basic circuit elements like resistor, capacitor, inductor, diodes, transistors, etc. in various combinations. Introduction of Boolean algebra and logic gates resulted in robust digital systems. So analog signals are converted into digital using analog to digital converter, and then it is processed in digital domain. So this is digital signal processing. Consider, for example, a CD which is made in a studio. The music is first converted into an electrical analog signal by a microphone. The electrical signal is converted into a sequence of zeros and ones by sampling. And the sequence of zeros and ones is etched into the spiral track of CD. So here we have converted the music, which is an analog signal, and we have stored it in a CD in the form of a digital representation. So what are the components of a discrete time signal processing system to convert an analog signal into a digital signal? So any analog signal is first given to an anti-aliasing filter. The purpose of the anti-aliasing filter is to enable signal reconstruction at the receiving end, and for this we consider sampling theorem. The samples should be done satisfying the sampling theorem. So sampling theorem is the sampling frequency should be greater than or equal to 2 times the maximum frequency present in the analog signal. Now after sample and hold operation, the analog signal is given to an analog to digital converter, which converts it into a sequence of zeros and ones. So any signal processing, digital signal processing like filtering operation is done, and then the output, which is in a digital form, is converted back to an analog, and the reconstruction filter enables the proper analog signal reconstruction at the receiving end. So converting a continuously changing waveform into a series of discrete levels is nothing but the digital signal processing. And for converting, the analog waveform is sliced into equal segments, and the waveform amplitude is measured in the middle of each segment. And the collection of measurements make up the digital representation of the waveform. So here we can see a sinusoidal waveform has been sampled, and the amplitudes of each of the sample taken is in analog form. So if this amplitude is discretized in level, then it becomes a digital signal. So what is the requirement, or why we have to go for DTSP system or a DSP system? Analog signal processing is achieved by using analog components such as resistors, capacitors, inductors. And the tolerances associated with these components, such as temperature, voltage changes, and then mechanical vibrations, all these can affect the effectiveness of the analog circuitry. So, if a digital signal processing is used with DSP, it is easy to change applications, correct applications, and update applications. Additionally, the advantage of DSP includes it reduces the noise susceptibility, the chip count, the development time, cost, and the power consumptions. So because of these advantages of DSP or digital signal processing over analog signal processing, we go for digital signal processing technology. Where are these signal processing applications used? Now we can see signal processing applications are used in audio signal processing, audio compression, image processing, speech recognition, video compression, digital communications, synthesizers, radar signal processing, sonar signal processing, financial signal processing, seismology and biomedicine. So in all walks of life, signal processing is there. Now if you look at audio signal processing, the electronic manipulation of audio signals is done. In the case of audio compression, to reduce the transmission bandwidth and the storage requirements of audio data, signal processing is used. So everywhere signal processing plays a vital role. Now let's look at some of the common applications of signal processing. So in consumer electronics, in the transportation sector, in medical field, in military sector, in remote sensing for climate monitoring, weather forecasting, and in military for surveillance, in medical sector for monitoring ECG, EEG, etc. Signal processing is used. Now some of the examples of signal processing is again reiterated over here. So we have computer graphics, image manipulation, then audio equalization, MP3 compression, in medical imaging such as MRI, seismic data processing, weather forecasting, etc. Now a typical signal processing problem is shown here, eliminating noise. So the first image shows a noisy ECG, and after processing the noise is removed and we get a clean ECG. This noise removal is done using signal processing algorithms. Correcting distortion. So we can see a blurred image over here, and we have seen a contrast enhanced image after signal processing. So this is possible because of signal processing. Extracting information from a measured signal. Consider determination of an aircraft position and its velocity. So this is done again by signal processing. By measuring the radar reflection from the aircraft, it is possible to measure the position and velocity. What are the skills required for a DSP engineer? A digital signal processing engineer is required to have knowledge on basics of C, C++, MATLAB, Python programming. So this is not limited to, but it is just a basic requirement that is expected of a digital signal processing engineer. So basics of C, C++ with the knowledge of fundamentals like control statement, looping statement and data type is important. Knowledge on MATLAB using the matrix laboratory as an important tool for any electronics engineer for signal processing. Knowledge on Python programming for machine learning, deep learning applications is required. Now, why we require signal processing knowledge? Because there is a growing demand for signal processing engineers, and it is not restricted to a single professional area. It is used in every sector including technology, manufacturing and electronics. For example, the healthcare sector uses signal processing for X-rays, MRIs and CT scans, allowing medical images to be analyzed and deciphered by complex data processing technique. Signals are also used in the finance sector to analyze and interpret financial data, to aid in decision making in trading and building stock portfolios. In the entertainment sector, the most uh, exhilarating new movies are produced by multi-resolution signal processing in digital cameras, making entertainment a lucrative market for people with this skill set. There is an ever dynamic consumer electronics industry where smartphones, wearable devices, and digital home assistants couldn't exist without signal processing engineers. So there is a growing demand for signal processing engineers, and with this I have given a brief introduction to signal processing, its significance and its role in our everyday life. So these are some of the references from where I have taken the images and the content. Thank you.